PLCnext first pillar is enhanced convenience. So use your favorite programming tool, and we are not going to load you in terms of any programming tool. In the morning, we just completed our workshop using PLCnext Engineer. That's our own tool. However, you are not limited by PLCnext Engineer. You can just use C, C Sharp. You can use Visual Studio, Eclipse, MATLAB Simulator, much more. Python, Java, .NET, Node.js, HTML, MySQL. And in our workshop, we just showcased by the end of that workshop, we just showcased with Node.js and Grafana based development as well. So that's our pillar number one. You are no longer limited by any particular programming tool. So enhanced convenience. Second one, enhanced connectivity. What is the second challenge of a classical PLC? With Phoenix contact, of course, I would say, hey, you can communicate only over Profinet protocol. Else you need to just go with certain gateways, third-party devices. Rockwell, Ethernet IP. Siemens again, Profinet. So vendor to vendor, your protocol changes. And there, my answer is enhanced connectivity. That is my second pillar of PLCnext. With future-proof connectivity, PLCnext can communicate. So here you can see the hardware. Okay, simple base hardware, right? PLCnext can provide 7.0. Again, this shows that PLCnext is no longer only a PLC. You can of course use it as an RTU, FRTU, because it supports 60870, 101, 104, 61850, DNP3, DLNS. For IP layer, again, MQTT, HTTP, SNMP, SMTP, OTC UA, client server, which we covered in the workshop today. That means PLCnext can again be used as an edge device. And much more, because I have no enough space here, so that's why I just put 3 dots. Many new protocols we developed, even here in India itself, like okay, for power transmission and distribution, we developed 20 plus legacy protocols into PLCnext device. So PLCnext technology enables the integration of current and future interface in PLCs, any SCADA system, or any cloud, let it be public, private cloud. Of course, you can simply connect. That also we just demonstrated during our workshop. So that's my second pillar, enhanced connectivity. Here is my third pillar, which is called enhanced performance. Enhanced performance is based on 2 USPs of PLCnext. One is ESM, we covered very much detail. ESM is actually execution and synchronization manager, which will make sure that your execution of different codes, like in my enhanced convenience, I told you that you can just develop your codes in multiple programming tools or languages. So now, some part of your code is like, for example, using ladder function block, controlling your machines or process. Another part you develop for your machine learning application, like in C++ or Python. So the ESM will make sure that this will get executed in parallel. Core 1 will execute your process control application, and core 2 will execute your Python application. So it will be a parallel execution. So this is called execution and synchronization manager without any interrupt. So that is USP number 1, which is a patented kind of technology for PLCnext. And the USP number 2 is GDS, Global Data Space. So wherever whatever applications we are developing, all those data will be available in a space called Global Data Space, which will make sure that okay, your RTO applications, PLC applications, machine learning applications can seamlessly exchange data between these applications in real time. So that is my USP number 2 for enhanced performance. So now we just covered enhanced convenience, enhanced connectivity, and enhanced performance of PLCnext. And the next pillar and most important one is enhanced freedom. Because of course you can just develop programming using multiple tools. That means you can develop many applications or apps for your PLCnext controller using high level languages or very ladder based function blocks, or then there is a digital marketplace called PLCnext Store, from where you can just simply download these apps, and that also be demonstrated. So you can have multiple apps developed on multiple open source software tools, and that can be used for your application development. Now, for example, so PLCnext you are just getting as a simple device. Now your task is to use it for pump control system, simple one. Then go to store, simply search pump control. You will get an app with the name pump control system. Download it, install it into controller, keep the IO quantities like maybe 32 input, 32 output, 4 input, 4 output. Your PLC programming plus HMI development, everything will be done in not less than, maybe not more than 5 minutes. So within 5 minutes, you can commission your pump control system using an app. Another use case, little bit more critical, burner management system, boiler control system. Go to store, search for boiler control system. Internationally approved boiler apps with functional safety and cyber security are available. Simply download it. Just like how you are just using your phone in Google Play Store and downloading the cam scanner app. So you are not worried about the source code of the cam scanner, right? You simply download, install, scan it. Download, install pump control, do it. Level control, do it. Data logging, do it. Edge applications. Like I'll just explain, I think here from industry apps. So one gentleman is here. So there was a use case for us and an international project just a few months before. They were using PLCnext as an edge device and collecting data from old Mitsubishi and local PLCs and of course HMD, they are all CNC machines. And 2 months before, we were not having a solution for collecting data from CNC machines directly. Because a CNC machine, mainly, for example, G Fanuc CNCs are there, and even Siemens CNCs are there. Fanuc, the library is called Focus. So those who are working in CNCs, you must be knowing. And Focus library cost will be more than 6 lakhs rupees for collecting data from a G Fanuc CNC machine. So 2 months before, we were not having a solution. Now, we have developed an application which can collect data from old series of PLCs of any make. It's not the major one of local Siemens. It's like Mitsubishi, Hitachi, Panasonic, Omron. So much more are there. Even I also don't know. So around more than 300 plus PLCs and CNCs are listed in my store, and I will just show you by end of this presentation, just like how it is working. So I mean, like, the communication part is open. It's a kind of evolution. So we are just the new solutions and technologies are being evolved. Okay, using this enhanced freedom. So that is my fourth pillar. So now we have covered enhanced convenience, enhanced connectivity, enhanced freedom, and enhanced performance. And we are going to our fifth pillar, so which is the last pillar. Again, another challenge of classical PLC. Enhanced security. Do you know any PLCs in the market? Even as I mentioned, like I have my own like very classical PLCs, very good range are here. Do you know any PLCs in the market which is cyber secure? You can name, have you used anything which is cyber secure so far? But cyber security, just in, if I just mention, okay, cyber security, it doesn't mean that like some because I have to always name a standard along with the term cybersecurity. Cybersecurity standards are two types. It's not two types, two standards are there. One is IT security and another is OT security. IT security, most of us are aware. It is called ISO 27001. So many institutions you can see it is ISO 27001 certificate company for IT security. Similar way, there is an OT security standard which is IEC 62443. To be more precise, it is 62443 as products 2. And I can bet none of the PLCs in the market at the moment is certified according to 62443 as products 2. More again precise security level 2 and ML maturity level 2. And this is the most important standard. There are much sub-standards are there. For example, here in India now CPRI certification is there. So 62351. So that's a part of cybersecurity. But in short, the classical PLCs, another challenge is that none of the PLCs right now available in the market, those are not cyber certified. Reason is, you take any PLCs and those PLCs are got designed at least 20 years before. You can just correct me, of course, if I'm wrong. Any PLCs you take, the code design of those PLCs happened 20 years before. And we were not having any security concerns 20 years before. So cybersecurity was not a part. No major design changes happened in PLCs since last 20 years. Reason is, if I'm launching a new PLC, I have to invest millions of dollars for approvals, ATEX approval, UL approval, a lot of SIL 6.508, 6.511. So a lot of approvals I have to just apply for. And after investing millions of dollars, I have to run this PLC for at least 30 terms. Your PLCnext device, you use it as a PLC, RTU, FRTU, edge device, edge controller, but it is having separate mechanism embedded in that for authentication, integrity, confidentiality, and availability. Authentication means, so let's call PLCnext as PLC now, okay, for simple understanding. My PLC know who is programming me. So Vishal is programming or Nikhil is programming. There are mechanisms which it can understand, which we discussed in the morning, called certificate and shaking. Of course, I can just load the certificates. So that is authentication. You can define the accounts, programmers with role-based access control. Okay, he is the admin, only he can download and upload the program. The other one is operator, he can see the values inside a PLC, not a SCADA, right? Of course, in SCADA is possible, but inside a PLC is possible. Confidentiality. OPC-UA based protocol security are there. Encrypted security, secure protocols are there. Again, 62351, which is for 60870. ACD officials are here and leave. So there, 60870 is again an encrypted protocol, 62351. So encrypted protocol for 60870. Now all ministry has mandated. That is embedded into this. This is the first controller certified according to 62351 or from CPRI. Availability, tamper protection, denial of service attack, regular monitoring. Even each scan cycle, it will parallelly monitor whether I am getting attacked or not. So those mechanisms are there, but okay, I am not just going into that much depth in cybersecurity part. But let's look into the security part. Of course, secure booting. It can just make sure that okay, it is running on the right firmware. Device identity management, device and update management. So device identity management, like PLC can detect the other devices with, for example, remote IOs. Even it's a different device, right? So which remote IO it is communicating, and that remote IO is running in the right firmware or a malware. encryption, role-based access control, trusted platform module, coding and logging, network segmentation, IP tables, LDAP configurations, device and update management or DOM. So these are embedded into my controller. It's very simple. It's not like okay, that much complex as you are seeing here. Connect my device, enter the IP address in your Google Chrome. All these configurations you can see. You don't need to use any software, you don't need to learn any new terminologies of cybersecurity. These are very common and you can see that which is embedded into my controller from the design stage. Of course, if you want to know more about 62443, we are open for that. Again, printouts because a lot of other cybersecurity features are there. And so that was my fifth pillar or fifth challenge of classical PLCs. I'm just again repeating that: enhanced convenience, enhanced connectivity, enhanced performance, enhanced freedom, and enhanced security. This is the internal architecture of PLCnext Technology. You can, and it's a kind of brief about what, in a nutshell, what we have explained so far. Okay, so you can see ESMs here, so multi-protocols, REST APIs, multiple and different protocols for different programming tools. Even you can use courses for programming. 61499, that is actually DCS programming tool. You can use for programming the PLCnext APIs. Now, one question is, what all features I just explained? It is a simple feature of a computer, right? Once you install, okay, use a Windows or Linux PC, do all these stuff, C#, Visual Basic, whatever things what I explained other than cybersecurity. Of course, cybersecurity, the normal PCs are following ISO 27000, so other than cybersecurity, what all features I explained, that can be simply available in your desktop PC. Then why I am just talking about rocket science here in PLCnext? Difference is, you cannot replace the PLC kind of device. It's not, let's use the term like industrial controller with a PC, because PCs run on non-real-time operating system. And what we need in industrial control is a real-time operating system. The difference between non-real-time, Windows is non-real-time, Linux is non-real-time, and we are using Linux RT files. So it's a real-time operating system of Linux. Simple term. If you turn on in your PC, if you switch on PowerPoint, Excel, Word together, sometimes PowerPoint will come. It will hang for a few seconds or minutes. Then sometimes Word will come first, sometimes Excel will come first. So you cannot manage the booting process or the application services in terms of determinism, like you cannot define the timing and priorities. So that is called a non-real-time behavior. So the real-time behavior is like, okay, if, for example, you are using functional safety, process control, like PID control, some data logging, some visualization inside a PC, and turn it on at least 5-10 minutes for booting, then sometimes visualization will come first, sometimes like PID, sometimes functional safety. So we should be able to manage this with the priority levels, and that's why we are using real-time Linux operating system inside PLCnext controller, and that's the difference how a PLCnext is different from the PC. Now, the controller part, of course, Nikhil already covered this hardware side. We have 1252, 2152 where we work most of the cases today. 3152, 4072, S and R. S is safety, R is redundant. Then PC, safety controller for wind turbines and highly mathematical calculations. So there is another controller. And we got virtual PLC next, where you need not to use a PLC hardware, use a PC. Now again another conflict will come. If I am using a PC, then PC is not real-time operating system as I mentioned. Then how can I run a virtual PLC it's not soft PLC, it's virtual PLC, it's different, but of course. So this question may come to your mind. The answer is, you can of course use a PC, and for PC we have Ubuntu Pro RTOS. Again, real-time operating system got launched by Linux. Now it's called Ubuntu Pro. If you are running Ubuntu Pro, of course you can just run virtual PLC. Else not. You can run, but it is not recommended. You will not get a real-time behavior. So that is virtual PLC. But the advantage of virtual PLCs come with 1000 IO points, 1000 variables, 5000, 10,000, 50,000, 100,000 variables or IO points. Of course, you need not to change your PLC license hardware. Keep the set capacities, run this virtual PLCs with multiple instances inside it. PC kind of hardware. So that is a concept of virtual PLCs. Use case is different, not in normal application. The use cases are like in data centers. So data centers are not very common in data, right? So here I think we don't have much, but can you know like just a 1 megawatt data center, how many IO points, PLC IO points, how many IO points are being used in a simple 1 megawatt or even half of that data center? 60,000 IO points, which is more than even like a oil and gas plant, right? So data centers are using more than 60,000 IO points even in a smaller, not containerized data center. Okay, just a kind of megawatt level data center. Simple data center is using more than 50,000 IO points. To handle 50,000 IO points, how many PLCs they have to use? More than 5,000, 10,000 PLCs for individual applications. Many applications are there in data center where PLCs are being used. BMS, HVAC system, chiller fan management system, solar system. Now it is hydrogen part is coming inside the data center. Rack monitoring system. So different applications are there. All put together, this much IO points are coming. But using a hardware-based PLCs are not feasible there. So that is the reason why virtual PLCs are being used in data center kind of applications. So just for the information part, redundancy mechanisms, just like a classical PLCs, you can have redundant configurations so that we have showcase and we explain. I'm not moving much faster. So now coming to a classical architecture where we are positioning PLCnext. We use PLCnext as a simple PLC to control your machines, data, or your process plants, so vessels, so the vessel management system, and I can just, I'm very much proud to say that in water metro, Kochi water metro, all the vessels completely powered by PLCnext technology. You can find 3 PLCnext controllers inside any water metro vessel. One is for propulsion control. It's a hybrid system, right? So the propulsion control, which got supplied from Sweden, it's not from India. So there, PLCnext is there. Alarm management system supplied from Phoenix, India, and vessel management system by India. So these 3 PLCnext control systems are there in your Kochi metro or water metro. So for the vessel management, just to mention the application. And the highest controller, the biggest or largest, I would say, there's a big controller of PLCnext with i7 processor, with touch screen, hot redundant with auto sync. It's S2 redundant with auto sync, handling much bigger IOs, and that is powering our quick power generation plant now. With the latest upgradation happened, they adopted PLCnext in a very high critical system. And we have very good applications of PLCnext where simple 2 and 5, which we were just playing in the morning. with a simple 2 and 5 controller with few ID cards, and we have applications handling more than 5,000, 3,000 IO points and redundancy with simple 2 and 5 in NLC commissioned by Telecom. And so that's why the application areas of PLCnext are wide. So I'm just trying to relate the application possibilities of PLCnext in our locally known areas. So with that functionalities, I can use PLCnext as a simple PLC. Of course, I can use PLCnext as an edge device for collecting data from different machines and PLCs. Edge computer for the machine learning deployment. And this is more detailed and a wonderful architecture of digital factory. How it works, just correlate it to your, so this is like a cabinet where I just mentioned data collection box. Another cabinet is there where I just mentioned smart production cabinet. So that's just, I'm just giving the name. There is no such cabinet, data collection cabinet or smart production cabinet. The name just be given. The idea is keep your cabinet ready in few set of IOs. On the left hand side and the right hand side in green color, you can see PLCnext apps from the store. If I want to just collect data, single point, double point, so the rest of your CTP remains, so your FRQ is ready. If you want to use RTU, much larger version of FRQ, go to store, couple it with multiple applications, not only 60870, 60870, 61850, DMP3, for example, 3 apps, use it however you want. If you don't want to use my apps, of course, third-party software apps are there. Single with, again, hundreds of protocols in a single disk. So that's how it is being used or utilized. So the PLCnext store, but so that's why, so I can just use it for utility metering, OE, condition-based monitoring. So we will explain it in detail, okay, how it can be used. So simple term, whatever be the challenges, of course, you can just use PLCnext for different applications. Now, I think we made a small setup here with one energy meter. So what I will do, I'll just, with a small demonstration, I'll just end my presentation. So, since it's not long enough to take, so what I was going to do, this IoT framework. So this is an app from my store. So I think I told to Madam in the morning, like we will just show one app, how an app works. Okay. So what we did, we just installed this IoT framework app into my PLCnext device here, and I arranged one energy meter, one Siemens PLC, just to show how simple communicating a third-party device using PLCnext store apps, right? So you can just open the browser. So we just installed IoT framework app into PLCnext device from the store. Of course, many of you are having the controller. Of course, please try this at your office. Just can you please close this and open a new tab, so that what you need to do after installation, open the browser, connect your PLCnext device. There, enter the IP address of your PLCnext device. So 1.10, right? Now IoT framework app has come. This is nothing, it's a web startup. or web HMI you can say. So it's a purely kind of HMI kind of stuff. Now you just log in using the username and password. So logged in, and this is the main screen. So what I selected here in my app, so it's a fresh controller, I just downloaded the app. You can see here, connector. So inside connector, I just selected, okay, I'm just using one energy meter and one Siemens controller, hence I selected S7 communication and energy meter here in my connector. You can find Ethernet IP connectors, analog input connectors, signal conditioning connectors, lot of connectors can be added. It's a customizable one. Okay, now I just selected for this case S7 communication. So select S7 communication. Just enter the IP address, click on config. So here just put 21. Right, save and connect. So its connection is being established. You can see here connection error because my IP address is wrong. Now again click config. It's 20, right? So now hold on. Here, this is a specific protocol in which I am not doing anything on my Siemens PLC. It is running as it is inside your plant. Connect a PLCnext device. Every Siemens PLC is coming with S7 TCP protocol embedded with the data. Connect Siemens PLC. Enter the IP address, select S7 TCP protocol in PLCnext, not in Siemens PLC. Okay, you are not touching Siemens PLC. Click Save and Connect. So enter the right IP address, 20. It's right, 20. Save and Connect. Now connection is being established. Running. Click on that box. Data block. Here you can see the Siemens reading coming from Siemens PLC. Can you please put some true or Boolean operations in Siemens PLC? So go to now wait, no issue, leave it. So but see, this is how actually data is coming. Now we will just go to the another connector, energy meter. Similar, we entered the IP address of energy meter. That energy meter is from Phoenix contact. So click on configure. Select energy meter, drop down list. So it will list what all energy meters are there. So you just select your model. This is possible not only with energy meter, it is possible with VFDs, flow meters, any kind of stuff, any kind of devices. We can create in the form of a drop down list, no code, few clicks. So that's the concept. The end user need not to code anything. He need to just do this with few clicks. So that's the idea. So select your energy meter. No problem. You just keep that your part. No, the other model, 777. 7XX, right. So I just selected that, then click Save and Connect. Disconnected, connection is being established, running. Click on that box. No, not config. That's also fine. All your data. For doing this kind of development, we need to spend more than a week time in engineering, which we are doing in few, not even minutes, with a proper app. Let's look into, you just connect both this thermal processing. we install another app which is called thermal processing or boiler management system, whatever we can just name it. So you can do oven control, thermal control, burner management, so any such kind of application. Again, you can see, you can just close this tab. Now see, the name got changed. Yeah, just insert the app. Fine, it's connected, right? Yeah. Now the name got changed. ITHE. ITHE means Industrial Thermal Processing, a different app. Okay, I understand. Now, what kind of burner system you are having? Select single burner, ratio control, lambda control. Select your burner. So just go to the single burner. Your P&I diagram, animations, everything is ready. Of course, this is customizable with alarm screens, and so you can change your P&I diagram according to your requirement. So this is actually coming as a single library with a complete path. Click on this PID controller. No, this. Yeah. Complete PID tuning. Ramp mode, auto tune mode, pre-tune mode. Just click some auto tune, for example. Your face plate key. Start auto tuning. Just imagine how difficult it was to auto tune your or even tune your PID and do a PID logic like this in the past, which we are simplifying through app-based approach. So this is applicable to even your I think valve control is also there. Go back to your home. I understood. The single burner again. Just click on some valve. So valve base plates will come. Again, manual mode, automatic mode. You can just do the manual operation and simulate it. So I hope like the concept of app is for us clear. This is one or two apps. Hundreds of apps are listed in the store. Hundreds of apps are not listed in the store, which we are just doing. For example, power plant controller in our transmission distribution. Very powerful apps are there. Many machine learning apps are not yet listed. So like that. And maybe by end of this presentation during dinner time, like if you have any queries, of course we can just show you the store and we can show you in live like how multiple protocols can be implemented. So this is the concept. Very simple, no code, few clicks in PLCnext App Store. So we just simply turn from simple data connector application to a burner control system. And that transition was without any coding with few clicks. Similar type of many applications are developed. Many of our partners, even in Kerala, they are developing customized apps according to their application requirements. So that's why I told you hundreds of apps are not listed in store because they are developing their own apps, putting in energy management. Very localized app is there. Just download it, all energy meter reading will be there. Monitoring the power supplies. Phoenix contact one customer requirement was there. They need to just, I think, oil and gas part of it. They need to monitor all twin 5th generation power supplies. It's a very famous power supplies from Phoenix contact. Every industry is having twin series power supplies. So there was a requirement to monitor all the twin series power supplies. And twin series, the new series is coming with Ionic protocol. A very plug and play monitoring solution. So many very simple to highly complex applications are being developed using PLCnext. I hope I could make that picture clear how PLCnext is unique. And by now I just used many terminologies I was just giving highlighting again and again. Reason is by end of the whole presentations we will just have a small question answer session on PLCnext and we'll give you some gifts those who are giving the right answers. I hope all of you enjoyed and listened carefully. So thank you very much. by Mr. Jayprakash. So yeah, it's over to you, JP.
Product that is called interface components. Am I audible to at the last person? Perfect, thank you. So the interface component basically the product which comes between the controller and field. From till now you have discussed everything about the controller, like what are the PLC and all. So we are going to discuss some hardware components. So basically interface containing the product like signal conditioning solutions. We have the relay board solutions in this product portfolio, and motor starters and speed starter, and electromechanical and solid state relays, and also some customer specific solution that comes under my product portfolio. So each product I will give you just brief information, and I expect from you if something more detail you require, you can even you can contact us because being limited time, definitely we cannot go in the detail. And also few new products which we added last year, product like installation contractors and PLC interface Internet gateway. Okay, going to the most learning item in interface component, and most you can say the without this device you cannot interface either DO or DI. So relay, this slim relay, we call it the original relay. Why we call it original relay? Here there are the behind there are the region that this slim relay was invented by the Phoenix contact. Earlier it was in green color, now it's become in grey color. It was a decision from the Phoenix Germany that all standard line of Phoenix product will be in grey. So that's why it's converted green to grey. So from where when we come, it was invented in 1997, just 27 year approximately a year back. So earlier, you know, like such kind of all panel was with the glass relay or sugar tube type of relay. So that time Germany has decided to innovate something, and the most important it was that product should be the reliable. And we come up with the slim relay, and the same size it can go for up to more than 5 and 6 relay. So that was the innovation that time, and it was very unique in the market. And even we are still having the highest selling relays from this portfolio. So that even continuously we are developing more and more product. Till now more than 700 unique part numbers are available in our portfolio. Initially we have started from these few numbers. There is one more thing, yes. So as I mentioned, like it's invention first by the Phoenix contact, and earlier there was also some patented by the Phoenix, but later it's like so many competitors, yes, they have developed, but still they have a few variants, not all. I will share you some specific application details how it having unique even in this slim relay. If we're talking about the product sales area, we are selling more than 12,000 customers till now. We sold after development of this product. Just the calculation here we got from the our development team that it's if say if we fit our slim relay on the So that is the number of relays we sold already in the market. So huge volume product that goes in the market. So definitely there will be some technology that making us to sell continue and generating the good volume. There are the video. There may be some issue that audio is not there, but this is showing like there are the two variants, 6.2 mm, that's a one changeover relay, and 14 mm for the two changeover relay. So there are the multiple variants are here. Even we have the some solid state relay inside in this, some also like a temperature modules and all. So variety of variants are available in this product. And sorting bridge which helping to minimize the wiring. Yeah, there is also like a clipping solution which can directly fit on the relay, and also some gateway which can be mounted directly on the relay. Yeah. So as in the video we have seen the technology. We have here shown like what is the inside, how it looks like. Inside it's like we call it lead frame technology. From start, we have this technology, and this is the unique technology getting manufactured by the this copper strip without man touch. It's all production going on in Germany, and it's a completely automated machine manufacture this relay. And this inside this strips acting as a heat sink and the region for the low hot spot, generating when even when you load this relay at 100% of its capacity.